Okay, so I'm going to start out a little bit earlier. My name is Alicia Lomas in the journey of making sure that you have strong, reliable data to unlock AI and machine learning type techniques. So, I've been in manufacturing for 20 years. I've always been an end user where we would build our own team, try to not be reliant on systems integrators. I was at factories like Oberto where there might be one HMI that you can do data logging and export to a CSV, or maybe I'd buy the Rockwell license, the RSLinks one that lets you do DD transfers to a Excel spreadsheet, to collect some data because we just weren't connected. But then I went to places like Chobani that was a beautiful OT network that was separate from IT, fully connected. We were, working with all of the levels of the business to make sure the data that the controls team was collecting was able to help finance and, capital projects and everything like that. And then so yeah, I started mostly in food and bev, and then more recently, I was at Redwood Materials doing EV battery recycling and battery material production, like cathode active material and copper foil. And most recently, I'm doing green natural gas, like electrolyzer using solar and direct air capture. So what I want to do today is give you guys some stories and some advice on the things that I'm running into it, throughout my career in just getting that base layer. My dream is I've always been pushing for data. No matter where I go, I want all of the data. But what I haven't been able to do is get to that next step like Ibrahim showed, which is taking all that data and doing, machine learning and AI techniques to even unlock more things. But even with just the solid, reliable data, we're able to get a lot of ROI. So there's a million automation pillars. This is one that I'm going to share today. I'm going to be focusing on the bottom portion, which is just all about the importance of the OT architecture, clean, contextualized data, making sure that your sensors are reliable, doing things that match your problem statements, not introducing bad data in that's just going to cause issues and not allow you to solve your problems. So, garbage in, garbage out. Somebody earlier in the L&T presentation said shit in, shit out, and that's living rent free in my head. I loved it. So, what I'm gonna share with you is 9 best practices with some stories of some of the challenges and how we overcome it to hopefully allow people to leave here and know where to get started. Let's say you do have a factory that's not connected. Where can you start, and how do we start unlocking some of these things and hopefully ease somebody's concerns about this is going to cost too much, because these things are just very important. And I've seen too many times where we put the cart before the horse and we start talking about AI and ML and we don't even have good data yet, and it's very crucial. So the first thing is getting the right people involved. So if you're not talking to your operators, you're not talking to your finance team, you're not understanding the workflows from your ERP system, you're not going to be setting yourself up for success. And I've seen this play out. So we had a dashboard that we were asked to do from the VP of engineering when I was at Chobani, and it was doing case counts and showing your production order. Well, we didn't go talk to ops. We just like threw them up there because they asked us to, and get them up by this date because Hamdi, the founder's coming. And it wasn't validated data. The operators didn't even know what we were doing. It didn't match up to their world, didn't help them in any way. So Hamdi walks out on the floor and is like, why does this not match what they're doing over here on the paper? What the hell is this? Like, I mean, it was just a failure, but it was like a really important lesson for me. When I have controls engineers, I'm like, if you're not going out on the floor, how are you even doing controls work? It's really, really important to see what people are struggling with and use them and leverage them, bring them along on your journey. You're not going to be able to take all of these groups within the company on the journey the whole way, but what you can do is have a steering committee with subject matter experts, your plant engineers, an operator, a maintenance person, and at least get everybody together and then get with your executives to know what you're trying to solve and what are the most important things to your bottom line, and get that agreement. And then along the way there's show and tell and giving people updates. Here's where we're at, which is going to continue to spark ideas and allow them to want to adopt it once you do roll it out. You have to get that buy-in. And this is the most important relationship from where I've come from. Um, when at Chobani, we had a completely separated OT network. We didn't have a great partnership with IT, and so we were having some issues with a lot of our data, and so we just kind of broke it out. And then you have to do special things to make sure the business team can see everything on the OT network. But to do this effectively, you want to have that relationship very strong, and everybody needs to understand that when it comes to OT, it's all about reliability, it's about availability. The slightest things can cause problems with your PLC if your network isn't built thinking of OT and it's more built thinking about IT stuff and all of that. So the best of both worlds would be tying everything together. So number 2 is investing in scalable, reliable architecture. This is an example of the OT managed switch layer that was one of the fixes to getting good network connectivity at Chobani. But this is definitely where you're working with your IT folks to make sure that everything can communicate and talk. Um, if you don't, like if you're having things drop out, then you're losing data. And now that's going to impact your ability to use the data effectively. One night, we basically at Redwood, we would lose data. We would have data drop out for like 10 seconds at a time at 2 a.m. every night. And the controls team talked to IT and they said, oh, we're not doing anything that should be impacting you at that time. So we jump on a call at 2 a.m., controls folks, IT folks, and sure enough, at 2 a.m., the data drops out and they're like, oh, yeah, our backups just started. And I'm like, but we asked you and you said nothing was happening at that time. And they stopped them, the data came back. And so, my point here is even though we had a special setup OT network, the integration then to the IT network and allowing IT to do their jobs using their deployment tools and their backup tools and all of that, that can also impact you. So it just keeps coming back to making sure you're all on the same page and making sure we're protecting this OT data so that you can actually use it. Defining a strong production model. If you're going to do an MES project, this is necessary, getting a production model. But what I find that this helps with is kind of just starting to think about your data mapping and really how you're going to go digitalize things. And it often allows you to find there's gaps. Like, oh, actually, so this is just a batch calcination process, taking EV batteries and cooking them down. You might find that, oh, I need to be able to split a lot when I'm going to go put this production stuff on the line, and I might have to send half this batch back because it's the wrong battery chemistry. So then you're like, oh, well, we don't have a way to do that. So we need to make sure we have a mechanism to be able to, reweigh on the line, send that back so it can go back to the warehouse as additional feedstock for future runs. And then standardizing naming conventions. Smart numbering is one of those things that I always get into arguments with people about because smart numberings always tend to end up being dumb because they break. So to me, it's like everything just has to have a unique name. And it starts with the ET, engineering technology, when you're designing the plant. You need to come up with your organization as to what this naming convention looks like. And then you and your operator are talking about the same device when it comes time to troubleshoot. So my team at Redwood, we all were on a rotation. There were 4 factories on that campus. So you'd have somebody call you up and, oh, hey, like wash tank 2 outlet valve won't open. What plant am I even in? Like, and what is the tag name? And, you're chasing your tails because if you have a good number, then they can just give you that. And I know which PLC to go into and help them solve the problem. And I wish this wasn't my reality, but this was also me at Redwood. We had all of these platforms, and we were doing this in the global supply chain issues. We built 4 factories in 3.5 years during the global supply chain issues, and we were a Siemens. Siemens was our plant, but we were buying stuff on eBay. We were buying stuff that we had to get the shortest lead time, so they couldn't go with our Siemens option. So But I think if you can set yourself up for success and draw a hard line and say, I will only take these one or two PLC platforms. And then I think my standards got lowered by this because I had no choice. I had to like go and I had to make everything talk and connected. You can do it, but now you've got to teach all your controls engineers all of these different programs. You have to do data protocol conversions at times. You have all these licenses that you have to handle. But if you can just get a consensus within the group, like, okay, I want this PLC, and then if you want to do a different PLC, like I'm going to make an exception for it, but it must at least speak OPC, or it must, have the right protocol to be able to communicate, making that easier. Because every time we did it, but like there was just so much complexity built into the system, so that every time you had to make a change, and we were making hundreds of changes a day because it's R&D, new industry, you can offset something and all of a sudden you have a lime silo that overfills because your data registers got kind of pushed down, and we didn't catch it. And none of this dev stuff, everything's on the fly, everything's in production. So at the last 3 startups I've been at, the first thing I've done is buy ignition and historize everything. And it's just very important. And I actually was able to save the company $150,000 because we were being audited for our air permit. And they needed to know from the last quarter how much our production lines were running to comply. And I was able to, because I historized everything, I was able to use the charting function in Ignition and do an export, and I knew where all my production lines were at, so we were able to save some money. And I think this is where you have to, like, the controls team has the foresight to like start logging things, and then ROI just comes around every corner, and people are like, oh, you just solved that. We're kind of like the detectives. Oh, we have a recall, or we have some quality issues, and then you're going into the historian and finding out why. It's just really, really important. Validate data in real time. So we talked about the Hamdi thing and how he didn't trust the data because it wasn't validated. But things like this, go down to the production line, look at the dashboard, work with the operators. And one thing I've uncovered before is like when they're taking their boxes of yogurt off the line, they're actually flagging a proc several times. So now you have inaccurate case counts. So there's a lot of levels to data validation. And again, use your resources, the people that are running these pieces of equipment every day, and we're probably doing paper processes. We're not going to boil the ocean, start small. So we had a sister plant in Germany doing battery recycling, and they were writing everything down and entering things in Excel spreadsheets. They didn't have any digitalization of their information for lots or weights or anything like that. So the first thing we did was just get them that. We have, lot creation, create our own internal raw material lot information with the weight and all of the important information with it, the manufacturer or data manufacturing, all of that that's important. And got them, scales that were connected. We got them barcode scanners, label printers, and just started collecting data, digitalizing, reducing errors. There were just tons of errors, and they were doing everything off these spreadsheets. And it was a mess. But we were actually able to get them 300,000 kilograms of dead inventory off their books just by going through this process. And within a month, now we know we have very solid data, and they can go back and get that stuff off of the books, which is a big problem for the logistics team and finance, of course. So documentation. I feel like a lot of engineers are like, we don't need documentation, let's just go do it. But it's so important. And I would say at a minimum, I think you need data mapping. You need to be documenting what APIs you're using. You need to, have a good knowledge of what you're building. And then also you need a decision register. So we need to know that the VP of software over here said that we're going to be using this platform, or we made the decision to go put work orders in MES because ERP is not ready. But now we know we can go back and integrate and fix that later, so that we just don't have a big spaghetti mess of things that these were stopgaps because we had to go. but we do want to do it right. We need to be able to come back to it. So, where to start? So, I think the pushback I've always seen is this is too expensive. We don't have servers. We don't want to run all this Cat 6. It's actually not that bad. So, I can do this, and I've done this now a couple of different times for about $25,000 and get data collecting. So, and this has just proved to be valuable over and over and over again. And, in some of these small startups, they're using, LabJack over here and this other Kian's data logger, and everything's in like CSV files. But now here you've got everything, and you've got your, prospective client where you can go look at your trends, and you can take like that R&D data and then watch it scale up as you build your first production line and then your factory. And start small. You can start on just little industrial PCs, and then next time you can buy a server. But you'll be able to prove and get ROIs around every corner with a pretty low investment. And so, yeah, the point here, what I want to just close with is data is so important. The architecture that it's built on, just making sure that everything is done in a way that that data can be used across the organization. And go find your gold. With AI and machine learning and a solid foundation of data, you're going to be solid. So, and if anybody wants to talk about taking some of my long time collected data and do some cool AI stuff with it, like, let's chat. I'm starting to think I might need to learn AI myself. So, yeah, that's what I have. Thank you.